Hello everyone, myself Deepthi. Now me and my team members Akhil and Sai Jayant are going to give a presentation regarding our case study on chromium. First we'll see what is chromium. Chromium is an open source platform which is used in building the browsers. Some of the popular browsers are Google Chrome and Microsoft Edge. Many other browsers like Opera is also built on chromium. The entire code base of chromium is developed and maintained by Google. Google started this firm in 2008 and allowed developers from outside to contribute to the Chromium. Google and Microsoft use Chromium, and on top of that, they add their own features. For managing and fixing the issues, their development team employs an issue tracking system. Chromium is programmed in such a way to crash in a controllable manner when memory is limited or other unusual situations arise. It does not have an auto update feature, so developers who are working on Chromium must update it manually. For developing Chromium, even Microsoft developers contribute to Chromium. A total of 36 different languages are used in developing the Chromium. A stable version will be released every 40 to 45 days. Even after being an open source project, it is well maintained with all the documents, changes in the codes, instructions for developers, and how to report any bug. Google also runs a bounty program in which developers who find out a bug in the code gets paid as well. Even after following all the best security practices, Chromium is prone to several security vulnerabilities. According to few reports, it is ranked as fourth in terms of the number of vulnerabilities disclosed by the software products. Coming to the assets of the Chromium browser are a few, but they are very important. The first and foremost important assets is the user data. With all the features that Chromium adds, saving username and password, user navigation history, personal information like address, phone number, which are used for autofill of the forms in the web pages. The other assets are browser data, which has the cookies and cache, which has store some of the sensitive information of the user, like the sensitive data, password, and for authentication as well. The user system in which he uses the browser will also be an asset because if the attacker breaches the security of the browser, he can get hold of the files in the system. The server where the Chromium is being hosted can also be affected by the hackers, and this can be an asset also. Coming to malicious actors, different kind of malicious actors that can attack users or cyber attackers who can take advantage of vulnerabilities within the code and use them against the users. And next is insider threat. Any developer within the organization or any developer who knows the code will take the advantage of the vulnerabilities and can steal the data. In most cases, detecting the insider threat is more difficult than detecting the external threats. As a result, insider threats must be addressed with the same caution as external attacks. From the Chromium documents, they expect two types of attackers: opportunistic and dedicated attackers. Opportunistic attackers are someone who looks for the chance and will attack on any user. The most common examples of such attackers are malware, ransomware, viruses, and worms. Coming to dedicated attackers, the attackers who look for a target and attack that single entity. Generally, social engineering and spear phishing are two common strategies used in targeted attacks. Coming to threats, using the stripe threat model, we came up with the following threats for the Chromium. By flooding any Chromium API with malicious requests, attackers can cause denial of service attack, which is one of the most common attack of the hackers try to attack the applications. If there is a lack of security within the websites or in the sandbox, remote code execution can be achieved. Without proper implementation of features like the autofill and saving username and password, it opens the door for the hackers to get access for which he is not authorized to and can cause the broken authentication as well. Spoofing of user actions is possible By replicating the user's actions and driving them to the malicious site, hackers can create dangerous websites and direct users to them. Here is where the attacker can gather the information he needs. Confidential and sensitive data leakage is possible if the user data is not properly secured.
So now let's see some of the vulnerabilities that we as a team have selected for this case study. So the current issue which we are looking at, this is related to incorrect input validation. And for this particular vulnerability, Chrome has paid the person who reported this bug a reward of $2,000. And this was first brought to their attention on Jan 23rd, 2018. And on April 2nd, 2018, a fix for this bug was integrated into the code. For this vulnerability, the CVE score was 6.8, and the actual bug was that the Chrome's debugger API, which lets you debug any website for any developer, um, and like this particular debugger API allowed to attach to any of the target. That means for a particular website, if it has any scripting access, then only those websites with an correct extension, the debugger API has to target only to that particular website. But in this case, the debugger API um, was getting attached to any of the targeted websites, and this allowed attackers to persuade the user to download an extension, and with that extension having not proper access to the website, but still this debugger API allowed attackers to attach to any of the websites and allowed them to debug the website. So um, the attacker in this particular scenario, the attacker can uh, change the settings of the user, and he can just do this by enabling the file access flag in the extensions. For this particular bug to fix it, the developers added an extra check to the render frame, uh, like DevTools agent host.ccc files code, and this allowed the Chrome, the developers to check for an extra input validation for that session, whether the extension and the website, which both are having this same scripting access or not, and then allowing this debugger to attach to that particular website. Now let's look at the another bug. This bug was initially reported on March 30, 2021, and the CVE score is 3.5 according to the 3.x score. But um, this particular bug is an high severity bug, and Chromium paid to the developer who has identified this bug of whopping amount of $15,000, and that shows us how significant that this bug is. This bug has been the background of this bug is that there's a function which generates a hash key for the entire website's data, and this data is being sent from renderer to the browser. So during this time, if any website does change their data, and the hash key would not be changed, because this is a but according to those reading those comments and analyzing them, we found out that this is a race time condition bug. That means whenever the hash key is being calculated, at the same time the data is being um, changed from the renderer side, and this was an uh, pretty big problem, because this generated hash key uh, doesn't know to which website that it's being associated with. So for this, what the developers have done is they came up with a solution of copy the data, save it, and while after calculating the hash key, once again check whether the hash key that's been calculated and the data is getting matched. So with this, they've implemented a new code in their files. And the file name is generated underscore code underscore cache.ccc. So this file actually allowed them um, in uh, in mitigating this problem. And this problem is also related to site isolation, which we'll be talking in Chromium's architecture in the next slide. Now let's discuss about the Chromium's architecture. Um, the main idea between like behind the Chromium's architecture is the team wanted to be a stable, a fast, and reliable browser. For this, they went with the multiprocess architecture. So, what's a multiprocess architecture? Um, in Chromium's architecture, we have like an uh, 2 to 3 process that's been running constantly in the background. The one is a browser process, the other one is an IO process, and the third one is the renderer process. The renderer process is where the data is being like the DOM object is being created on how to display the web page onto the browser's UI, and this data is being transported to the browser through IO. For this transporting of the messages, they've used interprocess communication that's called IPC, and IPC allows for the browser and for the browser process and the renderer process to attach, and they have an ID. With that ID, they send the messages to write renderer process. And what's a renderer process? For rendering, for the renderer process to happen, Chromium team went with the sandboxing technique. So for every tab a user opens in the browser, a sandbox is being created that's like a virtual environment just for the single tab process. That means this tab process will not be integrated or uh, communicating with other tab processes. That means if we have a 4 tabs open in a simultaneously in a Chrome, that means there are 4 sandboxing or 4 virtual environments that's been running in the background. So for each uh, this is called renderer. This entire process of sandboxing is called renderer, and each renderer has an render ID and the render context. So render view and render view host, these are all the components that each everything has, and these lets I mean like these components talk to each other via IPC, and these the processing is an asynchronous processing because they don't want to block the other tabs process or while communicating with browser and the other renderer. So let's say that one of the tab is corrupted and it won't render because of maybe the network problem or because of any attack that happened. So at this time, the processing and rendering will be handled by the render process associated with that tab. So even if that tab is closed or the faulty tab, the other processes, the other tabs will not be affected. They went with this because if even if one tab is getting attacked by any hacker, then they'll not. I mean, like the communication doesn't come outside of the sandboxing, so that it preserves the user's system files or system data in which the attacker can't come outside of the sandbox and then uh, manipulate or steal the user's data.
Coming to the code inspection, we have chosen two files. That is the password manager.cc and the permission manager.cc for inspecting the code. These two files deals with the sensitive information that is with the user's data. The password manager.cc deals with the user passwords, and the permission manager.cc file deals with the permissions from the users, like accepting these permissions or managing them. For inspecting the code in these files, we checked if there are any hard-coded values are there, or any strings are combined together, that is concatenated together, or any overflow is happening. That is, we checked for the boundary values in the loops in the code. Uh, Coming to the password manager.cc file, This file deals with the user passwords that are entered for the websites. The functionality of this file, that is the functionality of the code, is to save the passwords which are entered for the first time, or update the passwords if they are changed, and autofill the passwords when the user relogins to the website. Like when user enters the credentials, the code prompts the user to save the password instead of saving the password automatically. Whenever we enter the credentials for a website in Chrome, the Chrome asks us to choose if the password has to be saved, so that again when we relog in, it autofills the password. But if any wrong credentials are entered, or the page access is denied, or page not found error happens, the Chrome does not save these invalid credentials. This code also updates the password. That is, when we change the password for a website for which the credentials are already stored, the Chrome prompts the user to click on the update password and stores this new password for autofill purposes whenever we want to relog in again. The passwords are encrypted and stored in hash. Since this file has sensitive information, any security lapse can help attackers to have user passwords which will lead to data leakage or broken authentication vulnerabilities. One issue that was reported is with the bug ID 537823. This issue is that the password manager can be tricked to put one site's saved credentials into another site with HTTP authorization. The permission manager.cc file deals with the user permissions for a website. Like whenever we open a website in Chrome, we get some notifications asking us to give permissions for accessing the location or the microphone or camera. This is because of the permission manager file. These permissions are handled by this file. These permissions are related to the sensitive information, that is, a user gives permission to a location or access to the his camera or microphone. One issue that was reported is a bug with ID 9022427. The attackers were able to access the private and sensitive information like the camera or microphone or and the location information through bypassing the Chrome's permission authorization. Another bug was reported with CVID 5767, which has a severity score of 6.5. This bug has allowed attackers to convince the users and install a malicious application so that they can access the important information. This has happened because of the insufficient protection of the permission UI in the Chrome. To summarize, overall, Chromium is an open source platform which is used for building the browsers. Since it is an open source, many developers are involving in identifying the bugs, giving ideas to tackle these bugs, and writing code for this application. We have from the case study, we have observed that most of the bugs are related to the buffer overflow. We also observed that many developers, like most of the developers, are quickly responding to open issues and the bugs that are identified in Chromium. The Chrome Vulnerability Reward Program was launched to the developers who disclose the vulnerabilities in this Chrome application or this Chrome project, and make this Chrome more secure. Since this is a huge application and which has a lot of data of the historical vulnerabilities, this will help the developers in writing the code secure or writing the secure code in Chromium. Thank you.